Greetings, you've landed at the VUC, IP Communications and VoIP community. We would like to thank Simwood.com for their support. Simwood can turn you as a developer into a telco. Our hosted PBX is from OnSIP.com, and you can go to GetOnSIP.com for a URL people can click to call you. We've been privileged over the last 5 years to be using the best conference bridge on the planet. Yes, I'm talking about ZipDX.com, full color, full featured, full HD conference bridge. Our website, vuc.me on the webs, hosted by Bluehost.com. And our worldwide local rate dial-ins are from Voxbone.com. Okay, welcome to VUC 601, July 8th, 2016. We're going to be talking beamforming, not the kind of beams that you should never cross, presumably, but we'll talk about that in just a moment with our guest, and Michael is going to lead the session, and I love when he does that because I got nothing to do. But we do have to remind you about a fantastic event. I've been to at least 4 or 5 of these. Almost all of us have been to several of them. AstriCon, Asterisk User Conference and Expo, that this year is September 27th to 29th. It's at the Renaissance Glendale Hotel and Spa in Glendale, Arizona. I've never had the pleasure of being there, but I'm sure it's wonderful. Go to www.astricon.net. Check that out. We can never say enough good about it. You meet the greatest people there, and let's face it, you want to meet Allison Smith, if nobody else. Forget the rest. Okay, Michael, with that, turning it over to you, you'll introduce our guest and get the initial stuff started. Thanks, Michael.
Indeed, indeed. Well, let's see. Before we get into our guest, I should like to thank Emil from Atlassian/Jitsi for prodding me to get this done and also to pursue it. Because it turns out that Emil and I have used products from Phoenix Audio Technologies before. Quite a long time, and we were quite satisfied with him. And Emil would be here were he not for taking vacation on a Grecian island this week. So that is what it is. But I should like to welcome then, and if you could, Joe Marash, who is the founder and CEO of Phoenix Audio, and has a long history, I understand, in transducers and audio sensing and hydrophones and all kinds of interesting things. Thank you for joining us, Joe.
Thank you for having me.
So we always open with a question, and the question is something to the effect of, if you think back, what got you started in technology, and how did you find yourself on the path that you followed?
Well, it's actually a long story, so
we have time.
I graduated with an engineering degree back in the 80s, and I joined an R&D organization in Israel, which was basically developing all kind of stuff for the defense industry. And I ended up in the within the acoustic group, which was developing at that time all kind of passive sonars for submarines. My first task within the group was to develop a 96 hydrophone beamformer, which was implemented on what we call a flank array, which basically is mounted on the side of a submarine. And after a couple of years, I became the head of the group. We kept developing all kind of applications and DSP solutions for sonar systems. At some point in time, we decided to try to take the technology above water and developing similar technologies to be able to track acoustic events, if you may, above water, like sniper shots, you know, all kind of vehicles that cross a certain path, and things of that nature. And, you know, that was my beginning. Within this group, at some point, I've been approached many times by many companies which wanted to take this technology and try to implement it for other applications. I can give you a couple of examples. One of them wanted to be able to measure the thickness of a metal plate using acoustic technologies. Others wanted to monitor all kind of chemical processes, which using but just by listening to what's going on. And the list goes on and on and on. Of course, hearing aid, surveillance, and so on and so forth. I've tried to do it within this company that I worked for, but it was too defense-oriented, too government-oriented, and it just didn't work. They were not built for this type of adventures. The cost structure, the whole approach was not, was a little bit different. So I decided to take myself out of this organization and open and start a new company with the intention to use or utilize this technology for, if you may, civil or pseudo-civil applications. One of the first products that we developed was a surveillance array. And the idea was you sit in a restaurant and you want to listen to somebody across the floor from you and try to record what they're saying. So we took actually a couple of microphones, we embedded them within a briefcase, and we developed an adaptive beamformer that was very directional. You could sit and aim the briefcase, if you may, to this area that you wanted to listen to, and you made recordings. So that's how we started. The company was called Lamar Signal Processing at the time. That was 1993, if I remember correctly. We then took this technology to other areas. One of them was hearing aid. We developed a microphone array for the hearing aid industry. Another one was for video conferencing at the time. So there were a bunch of different applications that people, felt the need to be able to focus their hearing to a certain direction and enhance the experience. And we've tried to take our knowledge and technology and use it for this application. At some point, the company was acquired by Angio Electronics in the US. Angio at that time was developing headsets for a couple of industries. One of them was voice recognition for IBM, via voice, that was many years ago. And they wanted to get rid of the headsets basically and use a microphone array. So we became part of Angio Electronics and we developed microphone arrays for the voice recognition industry, and then later on for the car industry. So you drive in a car, sometimes it's a convertible car and you have a lot of noise, wind noise and so on and so forth. And the idea was to use a microphone array somewhere up in the next to the mirror or sun visor, and again be able to enhance the speech and eliminate the noise. The cooperation with Angio Electronics lasted for a couple of years, and then in 2004 we decided to break apart. And I started a new company, and I called it Phoenix Audio. Phoenix, rising from the ashes. That was the idea, and here we are. 12 years later, with Phoenix Audio.
That's most excellent, and also very interesting because we see a tremendous amount of research goes into governmental, military, industrial applications, and then finds its way into consumer applications later on down the road. My first encounter with Phoenix Audio was probably, I guess, maybe not too many years after you founded the company, and that I purchased one of these. And I was at the time doing a survey of different little USB connected audio devices for personal use, and there weren't that many around at the time. This Duet, though, it was I was so happy with it that, and it became noticed amongst my coworkers, and I ended up giving it to my boss at the time and purchasing several more for other folks. But I'm in a small office environment, so I have relatively modest requirements, which sort of, from the Duet, what was the product evolution, and how did we go from things like this? I know you did some installable equipment, but I don't know anything much about that. I'm more familiar with the personal endpoints, and I actually have a Spider behind me. So how did the products evolve as you went through Phoenix?
At the time that we started Phoenix Audio, that was 2004. There was no other good quality USB device for conferencing, and there are actually not too many video conferencing running on on a PC. So there was not the need was not there yet. It was just emerging, if you may. And there were a couple of companies that that began to come up with video conferencing applications, and they needed a USB device. And some of them approached me and asked me if we can develop such a thing. And the first product that we actually developed was called the Solo. The Solo is a microphone. It's not a speakerphone. It's a noise canceling USB echo canceling microphone, and that was the first product, and we sold quite a bit of those, and we're still selling it. To my surprise, we thought that this product will disappear in time, but there is still need for just a microphone. But of course, the main disadvantage of the Solo was that it didn't have a loudspeaker, so you would have to use PC speakers to connect to it in order to make use of the echo canceller. Now, in 2004, PC speakers were, something very commonly used. Today, I think, you see them less and less. So the need was to develop a product that had both a microphone and the loudspeaker. And again, the market at that time was desktop usage because these were the applications. The bigger conferencing room was still controlled by the big companies, the big codecs, complicated systems, and we didn't think that was the market for us. So we developed the Duet. Actually, we developed two versions of the Duet, and that was the flagship for many years. We actually even OEM'd the Duet to Plantronics. I don't know if many of you know it, but at some point, Plantronics sold the Duet under their brand name. So we sold a few, I would say many hundreds of thousands of those, and we're still selling them. And the nice thing about the Duet, if I may, is that they don't break. They last forever. So people still call us with a product that they bought like 8 years ago or 10 years ago, and they're still happy with them.
Oh yeah, and they're metal, and they were durable, and mine lived on the road for a year in my computer bag, and it was both it performed well, and also it enjoyed that life without being damaged.
So next product after the Duet was to try to address the larger conference room environment, and we developed a line of products called the Quattro. I think the first Quattro came out in 2009, and it went through a couple of generations. We actually had 3 major generations of the Quattro. At some point, the Quattro came with different interfaces, so you could use it as a USB device. You could also plug in a telephone interface. We supported both PSTN and SIP telephone interface. And again, the Quattro was the flagship for many years, but it became a little bit old, and we wanted to renew the technology and redevelop the whole product, and hence we came out with the Spider, which is now the product for. I'll show another version. The version that you're showing is with the dialer. This is the USB version of the product. So basically, the Spider is a 4-microphone beamforming product. The nice thing about the Spider is that it's daisy chainable, almost unlimited. You can daisy chain up to 15 units, and if each unit has a range of approximately 20 feet, then if you do the multiplication, you know that it can cover any size room, and I don't think there is any other product that can do that. Especially when you have more challenging rooms, like if you have a U-shaped table or people sitting in rows and so on and so forth. So for the less commonly used type conference rooms, this is the only product that can address the challenge.
Can we just for a second here, as you went from the solo through the duet, and these are not array type devices, but by the time you get into the Quattro and the Spider, you're now dealing with arrays. What kind of processing are you dealing with there? Is it simply a matter of selecting the microphone element nearest the speaker, or are you doing something more sophisticated to achieve the performance?
With the Quattro, it's a little bit more complicated, more sophisticated, not much more sophisticated, because you have 4 directional microphones. You don't just select one microphone. We don't, just do simple mixing, but we try to take a combination of a couple of microphones, and basically you create a couple of directional, if you make beams. These are very simplified beams. You sum up one way or another, 1 or 2 or 3 microphones, and then you look at the output and make a decision which one is the best. And if I may, the main challenge is making this decision, because you don't want, if somebody slams the door, you don't want the speakerphone to think that this is the right way, the right direction to listen to. So you need to have a sophisticated algorithm to decide whether this is relevant speech. Do you want to steer the beam towards this direction or not? So many times this is where the smart comes in.
Interesting. And so you're 4 microphones in the Spider, and then as you daisy chain the Spiders, it may be difficult to answer, but there must be a level of sophistication in dealing with which Spider you're listening to at the time then as well. So is that just an extension of the same sort of algorithm across devices, or is that something further?
It's a little bit more than that. You basically all the information is streamed to the main unit, which we call the master unit, and each one of the Spiders creates by itself some kind of a quality measure. So the Spider finds a direction that it likes the best, and gives it some kind of a score. Like, this is what I think about what I'm receiving right now, and this information is sent downstream to the master unit, that then deals with this information, decides which Spider to listen to. Maybe it's more than one Spider, maybe it's a combination, and the master unit does it using using this scoring mechanism. One other thing that we have developed and was published was actually when the Spider decides which direction to listen to, you don't just use the energy, but you use you are able to somehow decide if this energy is derived by reverb or is it direct audio. In many times, we found that the energy that you received from the reflection or the reverb energy is higher than the actually direct energy. So we were attempting to actually make this distinction and ignore the reverb as much as we can. And so the quality takes everything into account, the quality measure that each Spider picks up, and this audio is sent downstream, and the master unit uses it. There was another challenge. If you send all the information in a digital way, then you create a long delay. If you think about 15 units and you start streaming digital information downstream, then by the time the master unit gets the audio information, you created a major delay, and then maybe the information is not relevant anymore. We've encountered this challenge, especially when you have a U-shape table, then the first unit and the last unit are actually picking up the same person. They might be physically or geographically located very close to each other, while unit number 6 is farther away. So the way that we do it is some of the information is sent downstream in an analog way to eliminate any delay in the information, while the other information is sent digitally.
Oh, excellent.
So there is a lot of sophistication that goes into this daisy chain mechanism.
So you're really almost sensing then the topography of the devices, or the layout of the devices, and playing, doing some temporal analysis to understand what's going on across what is essentially a virtualized array, I would guess. Interesting. And now before we dive into talking about the Condor, which is actually your most recent product, I understand. What came before it? What would people do if they had a large, like a boardroom installation or something like that? How would they address it prior to the Condor, and so what led to the impetus for that product?
That's a good question. I mean, if you have a large conference room today, your options are limited. You can use a good quality speakerphone. Many of them have extension microphones, so you can extend it to one direction or the other direction. So the only other solution that I can think of is what we call installed rooms installation. So you put microphones, you drill them into the table, you put loudspeakers somewhere on the ceiling, and you use mixers. You use many companies make mixers. We do too. So all these microphones are fed into a big device that sits somewhere behind. The issue with this solution is that it's expensive, installation is complicated, and it's a very fixed installation. I mean, you drill the holes into the table, and then you have the microphones there. So these are the solutions that people could use for a large conference room, and I guess this is what they do.
Given that that's a fixed installation, and that I'm reminded of, when you see a couple of microphones built into a laptop, Apple are particularly good at this. They do a good job on echo cancellation because they know the geometry of the laptop. An Apple program, or even Skype on an Apple laptop, knows a reasonable amount about the microphone array. So when you do a fixed install like that, is it inherently better than a more portable kind of a solution, or is it just more expensive and more complicated?
Typically, it would be better. I mean, if you do it right, the magic formula is that if you get the microphone closer to your mouth, then you're better off. I mean, you use a headset right now, so your audio quality is probably better than mine. I'm using a Spider, which is like a couple of feet away from me. So it's not a fair competition. So definitely, if you use microphones buried into the table, and if you put enough of them around the table and you do the mixing correctly, then I would expect the audio quality to be excellent.
Okay.
But
there wasn't a fair question. You're right.
Sorry, go ahead.
I just have a closely held belief that one person in an office, a headset is a good solution, and that's what I prefer. But I accept that the minute another person joins me, a conference phone or a speakerphone is the way to do it. So moving forward, then, what market forces brought about the Condor, and could you tell us about that?
Yes. Well, there is, I would say, there was a specific type of setup which was not addressed correctly, in my opinion. Think about a smart board, somebody standing next to a smart board and making notes, and then you have people sitting behind the table. And so if you have a speakerphone on the table, then this speakerphone doesn't pick up the person, the lecturer, the person next to the screen, because it's farther away, and also this person many times is with its back to the speakerphone. So then you have to connect another microphone, maybe a lapel microphone, maybe I don't know, maybe a microphone that is embedded into the display, and you have to connect these two devices together. So honestly, again, if you ask me how people do it, I could think of, again, using a mixer. So you feed the speakerphone from the table to the mixer, and then the other microphone to the mixer. I could think of many compromises, but you know, it looks so much more natural to just put a microphone, a good microphone, on the screen that could pick up the whole room. Keep in mind that you have everything in this location. If you look, for example, at a Cisco system, you have the monitor, you have the codec, you have the camera. Everything is in the same location. The only thing that is not in the same location is the microphone. So it was a natural location for the microphone. But now the microphone needs to be able to pick up voices from a farther away distance. Hence the array technology. One more challenge that you know, people came to us and asked for a solution was to be able to use the internal speakers of the TV. Again, for the same reason, you have a screen with built-in loudspeakers, and you want to be able to use them. And if you have a speakerphone on the table and you want to use your TV speakers, then you have to feed the signal somehow back to the speakerphone for the echo canceling. So everything becomes so much more complicated. And so the Condor, the concept of putting a microphone array on the screen would just look very, very simple, very natural, and you know, hence the Condor.
Sure, and so just showing as I'm speaking, people will see it up close, a picture of a Condor mounted across a display. This was taken from Infocom. I think one of your resellers had promoted it to me. So the Condor is both then connected to the television and also to the computer that's running the client. And what's inside the Condor specifically? What are its particulars?
Let me bring one over here. So the Condor has 15 microphones. It's a 48-inch array. It's pretty good size. We thought it's not too big. You know, most monitors that you would use are bigger than the Condor. And you use the microphones to do the beamforming. So you create a couple of directional beams. These beams are fixed. Each one of them looks at a fixed direction. And then you feed the information, again, the same concept that we've discussed before. You feed the information to some kind of mixer that is built in. And this mixer makes a decision whether to use beam A, beam B, a combination of the two, and so on and so forth. The interface for the Condor, actually, this is the back panel of the Condor. So, you know, you can use it as a USB device. If you use it with a USB, it's powered by the USB, and that's a big advantage. You don't need anything else. You just connect it to your PC, and then that becomes your PC microphone. As far as the loudspeakers, you can feed the speakers from the TV back into the device, and we included an optical interface for that purpose. So you can use your TV speakers. You just need to feed the signal into the Condor, so the Condor can do the echo canceling. Or you can use an external loudspeaker, for example, a sound bar. So you have an optical output link. You can also use an analog link. Sometimes, you know, you use analog speakers. If you use it with the Cisco codec, for example, then you feed the signal from the speakers in an analog way. The only other thing that we wanted to add to the Condor was the ability to be networkable for a couple of reasons. One of them, to be able to control, because you have the Condor now, you want to control the volume, or you want to do something with it. How do you control it? I mean, it doesn't have any dial pad or anything on it. So we decided to make it, you know, to make it networkable, and then you can control it through the network. Now, while it's connected to the network, we also added a SIP client on it. So that eliminates the need to have any telephone in the room. So that makes the Condor basically the only audio device that you need in the room. You can connect it to the network and use the built-in SIP device that you have.
Okay. So when you say that the beams it presents are fixed, do they need to be set up? Are they defined at the point of installation, or are they something that the device does on its own?
They're pre-designed. All the beams, most of the design of the Condor was surrounding around the, excuse me for a second, the accurate design of the beams. So they overlap. They cover 180 degrees. The Condor doesn't listen to the backside of it, so it's only, to the front. So you have 180 degrees of coverage, and the beams overlap each other, and they're fixed. They're pre-designed, so you don't need to set up anything.
Okay, and 15 microphones. What's the logic behind that? I mean, it seems like you could have had 12, or there had to be some point in it. Also, kind of the dimensions. What advantage of the dimensions of the device?
In the article that I published, which initiated this whole discussion,
yeah.
I mentioned that the larger the array is, the narrower the beam could be. So we wanted to create an array which would be wide enough. 48 inches, just a number that was derived by the size of a typical monitor. We didn't want it to be too big. It looked like a good size array, and then we did a lot of analysis to see if we get the performance that we were looking for. 15 microphones again. The microphones have to be close enough to be able to prevent what we call aliasing without getting too much into it. If the microphones are too spread out, if you have a 48-inch array and you just put two microphones at the two edges, then you'll start getting the reflections of the beam. So you need the microphones to be close enough, and the higher the frequency, the closer the microphones. You don't need to have close microphones all across the array, and if you can pick through the Condor, if you happen to have one and you pick through the Condor, you see that the microphones are not spread evenly. In the middle, you have microphones which are very, next to it, very congested, very close to each other, and then they're spread out farther away, and you use different sets of microphones for different frequencies. That's the idea. It's a very well-known technique. The number 15, after doing a lot of analysis, we've spent many hours of simulating and designing the beams using simulated data, and that's the number we came up with. Of course, we wanted to minimize the number of microphones, but we didn't want to miss anything. So that's the number we came up with.
You hinted at something there about frequency response and sort of frequency dependence, the interaction of the microphones and such like. Is the Condor designed to do a full band audio, or is it bandwidth limited at the top end? Used to be that things like my headset are bandwidth constrained to 8 kilohertz passband. What's the Condor designed to do?
The Condor is up to 16 kilohertz. So we thought that's a good frequency to have. Most people can't hear anything above 16 kilohertz, and that's what most of the industry requires. I may say that many of the video conferencing applications that you have out there can't even handle 16 kilohertz. So that looked like a good number. The challenge in directionality is in the low end, not the high end. You can get very good directionality very quickly with a very small array. In the high frequencies, it's much more challenging in the low frequencies. So we go down all the way to 100 hertz approximately. So it's a full bandwidth product, very high quality.
It's very interesting. One of the things that, just an observation, one of the things that I've noticed is most meeting rooms or conference rooms that are set up for video conferencing or audio conferencing, oftentimes there is the presumption that if I flop a device on the table like this, that makes it a conference room, and they don't even have curtains or anything like that. They don't have any upholstery. They may have, very hard acoustic surfaces on all sides. Consequently, the device struggles, or is going to struggle, because it's dealing with a complex, unnecessarily complex, often acoustic environment. So, and how's it being received, I guess? And then we'll start readying the audience. We'll take some questions if people have questions shortly.
Actually, it was received tremendously well. I mean, it's we launched it. I use the term very carefully. We didn't just send units out. We had no demo units to be sent out. When people ordered a couple of Condors, we would tell them, maybe you should buy one first, try it out, and see if you like it. Because it's not a product for everyone. We don't sell it as a solution for everything. If you have a very challenging room, it's very big, then we would prefer that you buy the spiders. It might be a better solution for you. So it's an excellent solution for certain types of certain size rooms, and it's sometimes very difficult to predict which room would like the Condor and which room wouldn't like the Condor. So with that being said, people insisted on getting the Condors. People don't want desktop speakerphones. I'm actually a bit surprised by the overwhelming response. I mean, whoever we speak with, we tell them, maybe your room should use spiders. You can daisy chain as many as you want. There is always a room for redundancy. If the room is more challenging, you can throw in another spider. Have a better coverage. But they insist on getting the Condors. You just free them from all cabling and devices on the table. So far, the reception was overwhelmingly good.
I certainly understand. If somebody has a spider and they have to put that device out on the table, that kind of runs counter to the idea, which we see in some places where they have a cart and the monitor is on a cart with the codec, and it's a roll-around kind of thing. And if they can install the Condor to the cart, then they've got a completely portable solution that maybe addresses whatever room they might need it in at a given moment. Is there any particular vertical that you've seen sort of pick up more quickly than others, medical or corporate or governmental or?
The first market that we try to target is people that use smart boards, because I think that's an agile market. Like if you think of the Surface Hub type of a product, or the Cisco MX800, 700, these are products that typically are not meant for large rooms, but encompass everything in one location. So these are the markets that we try to target. But honestly, we've been selling them all across the board: education market, telemedicine market, you name it. People just, and it doesn't matter if it's on a cart or a fixed installation. They prefer to put it on the wall and use a Condor rather than use any other solution.
Okay.
We've seen people that want to put it on different walls, on the ceiling. Installations that we haven't had to try ourselves. But it's like you get the feeling that the market is ahead of what the vendors can offer. So
interesting. We have a couple of questions, so Mr. Bodie, feel free to unmute yourself and jump in.
Hi, Joe. I think this is a wonderful product, and I think you've done a brilliant job at answering all the questions that initially I had, having gone through the specifications. Now, the bit that really interests me now are the applications that you could do with this technology that you're currently not doing. So, for example, would it be possible to use the direction finding capability of a Condor to do something like steering video? So somebody speaks and then you point the camera at them.
Well, sure. One thing that I didn't mention about the Condor is that when the Condor selects a certain beam, it actually lights an LED. So you get the feedback when you use it as to which direction is the Condor listening to right now. And we actually provide this information through the USB. So there is a protocol. We didn't release it yet to the public, but we're going to release it real soon, in which you could actually tap into the USB protocol, USB messages that we're sending to the PC, and get the directional information. it's a little bit. I'm sorry.
Yeah,
Go ahead.
you've anticipated my next question, and that's exactly what I wanted to know. Would you be willing to make this directional information available? And the answer is clearly yes, I think.
Yeah, yes, we have a couple of customers that are interested, and I may, if you're talking about technology, there are two different directions that we find. One of them is good for audio, and the other one is for video. Reason is that the audio, we can jump beams. We can jump from beam 1 to beam 5 very quickly, and if we do it right and we do it smoothly, you wouldn't notice. Well, if you do it with video, you would absolutely notice if we jump from one person to the other. So there are different types of, if you may, smoothing technologies for the direction information. And we've done direction finding many years ago. 20 years ago, there was a company called Vicon that developed. It was called the Voice Finder, if I'm not mistaken, and that was a 4-microphone array that we developed for the purpose of direction finding more than audio. So we've been doing direction finding using microphone arrays for many years, and this same technology is implemented, or similar technology is implemented in the Condor itself, and this information will be available to our customers.
Brilliant. Well, the sort of thing I'd like to do with it is have a Condor watching a room, and then if there's any kind of audio signal within that room, then we just point a camera at it.
Yes. Yeah. This, as I said, we're going to integrate it with a couple of partners of ours that are in the camera business, and they would have to write the code to steer the camera, but the information is going to be available.
These guys, and because you're you seem to be addressing the huddle room space, or what people call the huddle room market, which is sort of smaller, mid-sized conference rooms. The PTZ cameras that have external input, so you could create a mapping between the beam that you're using and a particular PTZ preset that would steer things around. I think what other companies have found, though, is you need 2 cameras and you need to do some switching so you can kind of smoothly go from one preset to the other without having all the motion. But that would be, as you say, for the camera vendor to take care of. So, any other questions? Tim? I'm picking on Tim because I can't see him. So.
Oh, I've got another one.
Go ahead, James, then.
Yeah. Would it be possible to do produce a completely different product, one that actively pings and looks for reflections, so sonar, room sonar. So you're looking for things that move in the room and things that change, and then identify what they are.
For what application?
Well, I'm thinking about possibly security, but home automation type things. Well, I'll give you an application. I have a problem on my patio with we keep fluffy bantams here, and Tim's heard this one before, and they come and sit on my my patio furniture and leave little presents for me, and so we've been devising all kinds of outrageous devices for making sure they go away, and so I would love to have a sound-based thing which listens for chicken noises, identifies where they are, and then squirts them with water or something like that.
All these years we've been focusing on passive type of applications. Of course you can, I imagine you can create an active type of sonar, sending beams or sending some kind of a sound wave and try to listen to the reflections. This is not something that we've done in the past, but we did do all kind of detection systems that try to detect protruders, or we even had an application in which we try to create what we call an acoustic fence, a fence that will detect the location of somebody trying to cut a, let's say, a prison fence, and so on and so forth. So yes, you can do this kind of stuff. We're not in the in this business anymore. You know, there is enough for us in the video conferencing business. There is one more thing that I didn't mention before that we're very much involved in. We're also in the OEM business, so some of our technologies are available on daughter boards. So that if, for example, you develop a medical cart or an ATM and you want to incorporate your own microphone in it, then you can buy the technology from us in a form of a daughter board. I'll show you an example. I have one. I happen to have one over here. So this is an example of a daughter board that we sell to one of our customers, and basically has a very simple, you know, array technology in it. It has echo canceling, noise canceling. So this is another activity that we are involved in very heavily into the kiosks type of applications.
Doesn't this just tap the sort of the early IoT market in an interesting way, because people are taking, you know, small platforms, BeagleBoards and BeagleBones and Raspberry Pis and whatnot, and want to add various different capabilities to them, but oftentimes their onboard audio handling is simplistic. That is a logical lead into Tim, I'm sure.
So I actually did have a question which may possibly been answered, but I had to step away for a minute in the middle. So I'll apologize if you already said this. But how do you daisy chain the spiders together? What's the cabling between them, or do you do that over a network, or how does that play out?
No, it's not over network. We use a Cat5 or Cat6 or Cat7 cable, a standard Ethernet cable between the units. This cable is used for both the data and the power, but it's our own proprietary protocol. What I did mention before is that in order to prevent the delay over a very long chain of, let's say, 15 units, some of the data that goes through these cables is analog, some of them is digital, and also the power. The nice thing about the daisy chaining is that you can power all the units from a central location. You don't need to connect each one of them to power. So it's a single cable that goes between the units.
So in a room situation, you'd have dedicated, if they were fixed positions, you'd have dedicated cable between them. But that wouldn't be just, that could be Cat5, but it would be specifically purposed for this. I mean, it's not like power over Ethernet or anything standard.
Yes, that's true. You can't connect it to your network. They don't talk to each other through the network. You know, there is a cable. Where's the? If you look, I don't know if you can see it, but over here there are two Ethernet connectors. One of them is called link up, and one of them is called link down. So you basically connect the units between them using a dedicated cable.
Okay, and on the network question, the Condor has a SIP client. Did you say what codecs were supported on that SIP client?
I think the standard 711, 722, and a bunch of others. You know.
No Opus?
I'm sorry?
Opus at all? Or AMR are the two that we would be very interested in.
I'm not sure. I need to check on it, but I mean the standard. If you know, most networks would support the type of codecs that we use, so you know, it'll be selected automatically. We are not in the business of developing codecs, so we use the standard codecs that you have in the industry. Nothing.
Sure. I mean, you know, the two you mentioned are the obvious ones for these kinds of things, but we're increasingly, particularly with this sort of technology, the WebRTC technology, we're increasingly seeing the benefits of things like Opus, where, you know, dropping the odd packet doesn't ruin the audio quality, and also if there's more bandwidth available, it will take advantage of it and give you better sound dynamically. So those sorts of behaviors are starting to become available in desktops and laptops and stuff like that. And I'm just wondering whether we're seeing those codecs kind of head back into the conference room space as well. It would be really nice if we did, but I suppose there's no immediate hurry. I had one more question, which is sort of in the IoT space, which was around provisioning. So how do you provision the Condor? How do you set it up with its SIP address and SIP credentials and that kind of stuff, given that it's got kind of pretty much no user interface?
Well, there is a user interface. It's through the network. So the Condor has a built-in GUI. You need to know the IP address that the Condor has received. So you either check it through your network. There is an application on that you can run on an iPhone or an iPad or on your PC that will show all the Phoenix devices, all the SIP or networkable Phoenix devices, and it'll tell you what's the IP address, and then you log into the IP address and you can provision it through there. There's also all kind of the standard automatic provisioning. Typically, they are more common when you have when you try to install many units and you don't want to log into each one of them. You want it to be done automatically.
Right. So you configure a file in advance and then they pull out from that.
So the Condor supports this type of provisioning. So it will go to a certain address and pick up the MAC all the username and password and so on and so forth.
So the iPhone app presumably has to be on the same Wi-Fi or at least the same network as the Condor to work, or does it go through a cloud-based service?
No, it has to be on the same network. And it also has some kind of a security feature in which you can tell you can set it up so that a particular iPhone will be able to control the Condor, any iPhone, or you can also set it up so a particular iPhone would be able to control it, but you would have to put in a password every time you log in. So the idea was that you could, for example, set up a dedicated iPad in your conference room to become the dialer for the Condor, or you can allow anyone that enters the room to do the dialing. A similar application is also available on a PC, not just an iPhone.
Do you have any thoughts you care to say out loud about the audio quality on tablets? So I mean, you mentioned the iPad, but there are also the kind of equivalent Android devices. Have you kind of listened and played with those to see what they're like?
I don't think I can make any specific comment. I mean, the challenge is when you try to get away from the tablet, it's definitely not enough. I mean, we use the Condor for rooms up to 20 or 30 feet in length. Obviously, a tablet is not designed for this type of.
No, I suppose it's more of a kind of. It's the step down from a single spider, basically.
Yeah, I can tell you that I can compare a good quality, for example, the spider that I'm using, to the internal microphone of my laptop. I'm not saying that I can't use the internal microphone. I can, but the experience is totally different. Now, depending on what you use the audio for, I mean, I use all kind of conferencing applications many hours a day because I need to talk to different groups that we work with around the world. So, if this is something that you do for a couple of hours a day, it becomes a big difference. If it's a convenient audio that you can lean back and talk softly, or if it's a challenge, to understand what people are saying, or you need to raise your voice and so on and so forth.
Right. No, I mean, I totally agree. I was, when I looked at this a long time ago, I was quite surprised at how good for what it was the iPad's audio was. If you compare that with a laptop, for example, I found certainly that when they first came out, the iPads were surprisingly good. I mean, I think things have moved on since then, but they were, they were better than I expected, let's say.
Okay.
Curious. And yet, the iPad oftentimes is it's the way that we set up a conference call if you're in a meeting room, but it's not the way that we have the conference call necessarily, because the display is so small it only really accommodates an individual.
Well, and they're simply not loud enough for a full room. I mean, if you've got one on your desk in an office, that's one thing, but a conference room, they're simply not, it's not enough meat behind those speakers for that.
Yeah.
Keep in mind that you have people sitting around the table, and also, as I mentioned before, many times you have the power hub type of devices that you may have somebody up, at the board, and is very far away from your audio device. So you need to be able to address all these participants.
Oh, and these are very real circumstances, because there's at least one other manufacturer I know that makes a conference phone with, actually 2 or 3 now, with decked removable microphones that you can clip on your shirt and walk over to the whiteboard and not be left out of the conversation just because you have to go to the whiteboard. So this the circumstance is very real. The solutions sometimes look a little odd, but well, we're coming up to an hour, so let me see if there's any further questions from anybody else. We've had a reasonable number on ZipDX listening in audio and a handful watching the live stream, and I'm very grateful for our regular panel here. I had one other question, which is maybe going a little backwards, but I wanted to ask about the evolution of microphones, in your opinion. And now, bear in mind, I come from a recording studio broadcasting background, so microphones have gotten cheaper and they've gotten better, but they're big, and the average performance of an average microphone for an average price has gotten better over time. Have you seen microphones in these applications and the relevant little electronics associated with them? Have they gotten a lot better? Is it easier for you to design the Condor now than it would have been 5 or 10 years ago?
I don't think so. I didn't see much of evolution in the development of the microphone elements themselves. But there is a big difference between designing a broadcasting microphone and a microphone for the Condor. The reason is, there is a parameter that it's called dynamic range, or noise floor of a broadcasting microphone. The broadcasting microphone needs to be, on the one hand, very sensitive, on the other hand, not create any noise of itself. While when you work in a conferencing environment, that's not a real requirement. I mean, the noise, the acoustic noise, the real noise, is much higher than the electronic noise. So you can use, you may say, a lower quality microphones, and they're pretty good. They're pretty good. I can tell you that 20 years ago the microphones were not good. There's a company called Knowles that is making microphones for the hearing aid industry. The microphones were always excellent. There are other good microphones, but these are not the microphones that you use for the Condor. Are very low cost. They're good microphones, but they're not broadcasting microphones.
Okay, and then moving back into the product, the electronics, the silicon available to you to implement the smarts that go on. Of course, that's been getting better over time as well. So presumably, I guess my point being, presumably the products get better over time because all the foundational elements improve.
I can tell you that every no more than 2 years we entirely changed the inner guts of our products. The Duet that you've shown before has gone through 4 generations, and it's a totally different DSP today. So the DSPs are becoming better. The A to D converters are becoming better. The whole electronics is becoming better. So we try to use the best that there is in the market, and we end up redesigning and revamping the inner guts of our products every couple of years. Sometimes the customers don't even know it, but things are improving, definitely.
Excellent. Well, and with that, I think I will call for any further questions, and I don't see any popping. We've run up to an hour. So perhaps I should let you get on with your day, and thank you very much for coming to talk to us. And I look forward to laying hands on one. I'm actually going to be doing a little bit of a review effort with the spider that Laura sent. That's in progress and forthcoming. And thank you again.
Thank you so much for having me.
All right, gentlemen. Good night.